Oh, sorry about that, everybody. I had my microphone muted. But I hope you're all doing well. How is Global Hack Week going for you so far? We're pretty far into the week, and I'm curious how people have been doing. Hello there, Bug Breaker. So we're going to begin today with a challenge, actually. And I'm going to be giving you all 15 minutes to complete this challenge. And it's the application of our notebook from last time to disease detection um, in the tomato plant leaves. So you are going to be using the flower transfer notebook from Google Colab. Let me send that over. It's in the chat, and you have the data access to plant data notebook. Let me send that link as well. So I want you to try and implement this plant data notebook and use that to your advantage. You're going to try and apply what you found in the flower transfer learning notebook to this plant data. So I'm going to go ahead and give you all 15 minutes to work on this. And this will just be a nice exercise for us to try at the start today. Sorry, I'm just trying to get a timer to go, if I can. Oh, there it goes. Okay. Sorry about that. Everybody, that concludes our 15-minute warm-up this morning. And we're going to be going over the solution. So you probably remember from last time that we spoke about this concept called transfer learning. But before we get into, and we're definitely going to cover this, but before we get into it, I want to actually mention some of the comments that we've received. So StarCrusher223 says, "Hey Stephen, I'm working on creating a web app using Streamlit that includes all the classification algorithms you've taught till now." So StarCrusher, thank you so much for sharing that feedback. If you'd like any feedback on your web app, feel free to reach out. That sounds like a great project. And I'm glad that you've thought the algorithms are useful and interesting. Sudesh says, very excited about the session. Hi there, Sudesh. Really great to have you in the stream. And Stefan says, hi everyone. So hi there. And now I'm going to be showing my screen, which is the transfer learning application that we saw last time. This is an idea which is basically fundamental to a lot of machine learning algorithms that are constructed these days, which is that you would pre-train a model on a very large data set, hundreds of thousands of images. And that pre-trained data set, that pre-trained algorithm can then be leveraged for a new purpose. So in this context, we have transfer learning to classify flowers. And if you look at our plant disease detection, we can actually modify this book with simply the plant data files. So I'll share this tab instead, which I've titled Application to Disease Detection. And we have mounting our Google Drive. And again, the goal was to apply this transfer learning algorithm. I guess I won't connect it for now, but you can connect yours. You'll need this command. I'll share this, by the way. This is the application to disease detection version. And so you'll mount your Google Drive onto this application. That'll allow the notebook to access all the files in your Google Drive. And the plant data folder is one of them. All right. And so we can run all of the same files that we ran last time, except we'll just replace this flowers directory with the plant data directory. That's really the only change we need to make to this workflow. And then you'll remember that we can adjust parameters like the learning rate. We can adjust the train test split and the batch size, things like that. And we will get a result. So I highly encourage you all to try this out. I'm not actually going to show on stream because we sort of did this workflow yesterday, and I don't want to sort of spend time on it today. But I highly encourage you to try it out. And actually, there's another data set which I will show, which is about ripeness. So let me show that one as well. And someone in the Today in Global Hack Week stream asked about this one, but this is called banana data. Let me share that. Oh, yes, definitely can remove the banner link. Thank you for sharing, Maruti. Oh, I realize my camera is not in the frame. This is another data set which you can also try your classification algorithm on. So in this context, we have some bananas, and each folder represents different kind of banana. So this is green, totally unripe banana. Here's some mid-ripened bananas. And here's some over-ripened bananas. So you can see we have all of these categories, and given a new banana, let's say we want to know whether it's good to sell this banana or whether we cannot sell that banana because it is too ripe. Um, that would be a way for us to classify such things. So I highly recommend you play with this data set as well. And there are some suggestions at the bottom of this notebook, which are given to you by the TensorFlow community. One of them is to try a different image model. So you saw last session that we have our TensorFlow hub where you can see and have access to many different image models, pre-trained models specifically designed for transfer learning. And so you could try a different one and see if there's a better algorithm other than this MobileNet module. All right. Then there's another idea you can try, which is to stack a hidden layer between extracted image features and the linear classifier. So this would just be adding an additional layer to your neural network. And in this example, they suggest that you actually have a ReLU activation function and see if that would change the test accuracy. Exercise 3 is to change the hyperparameter. So we talked a little bit about this idea. And also trying a different optimizer. So the optimizer is that very final step where we're using the outputs of the pre-trained model of that feature vector to go ahead and try and make a final decision, a final classification. And you could use a different optimizer that's not gradient descent, such as the AdaGrad optimizer. So I highly recommend, if you have some extra time after this workshop, these are some great activities to dive into. All right. So this mom says, can you please discuss techniques/tips for handling outliers during data pre-processing? So this is a great question. And I'm not sure if you've heard of some common definitions of outlier, but one of them is that you have a point which is 1.5 times greater than the interquartile range. So let me show that. So here's just a quick search here, and it's showing that if you have some data set, you can compute the interquartile range, which is the 25th percentile and the 75th percentile. I'll go ahead and put a command in the chat for this, where you put your data, and let's say you want to calculate 25th percentile. So this would just be an example of how to calculate that range, the points in this data distribution. But the outliers, a common definition is that they're 1.5 times greater or smaller than than this region called the interquartile range. So that's one way you can define and remove outliers in pre-processing stage. But to be honest, this technique of removing outliers is as much of an art as it is a science, because you kind of have to decide what is an outlier, and that can lead to subjective situations. So that actually melds very well with a workshop that we are planning for today. and it's going to be the next stage of our learnings, this track, and it's called the Data Science Workshop. So this is a GitHub repository that I created a few months back, and it has a few exercises for us to work on regarding data science. And this is sort of the last thing I want to cover in this track series. We've already covered so many different machine learning algorithms, such as transfer learning, um, k-means clustering, and a random forest, and Markov decision process. Let's talk a little bit about the science of manipulating data, and we're going to break it down into some basic concepts. And so I want you all to go to this website, and if you want, you can download this to your local computer, this data science workshop, and yeah. Just going to give everyone a second to do that. I'm going to do that myself, actually. Um, Open it up in Visual Studio Code for all of you to see. I see. I'm applying the algorithms you taught us on a music genre classifier, and the outliers are very much affecting my model's performance. Um, yeah, so that's a good question. I think so. How are you? What features are you using for this classifier? I would try different combinations of features for your classification, and see if some are more resistant to outliers than others. Yeah, that would be my first suggestion. And the second suggestion is to tune your hyperparameters. See if you can improve the fit to the outliers by training for a longer period of time, for example. Um, uh, in the case of our learning rate example, or by adding more estimators in the case of our random forest example. I highly recommend to play with those hyperparameters. And the final suggestion I will give to you is attempt to increase the training size, the size of your training data set, because that will improve the coverage of outliers in your model. I know that that's actually really not as simple as it sounds, because a lot of the times we don't have more data. But if you do have more data, definitely try to increase the training size. You can even play with the percentages. So if you're doing 80-20 right now, you can do 85% training, 15% testing. Yeah, no problem. Yeah, 50,000, that should be enough to increase your training data set. You should be able to increase your training data set a lot, actually. So see if you can play with that train test split as well. And those are some ideas for you, but I hope that helps. You're welcome, S Mom, for that. But we're actually going to talk a little bit about some of these concepts as well, such as outliers today. Okay. So first, I want to dive into chapter 1, and I want to show you all a little bit about these data science tools. We've been using a lot of these without realizing it throughout this workshop, but I wanted to focus on them and make sure that you have them installed on your own computer. And so we've been using Jupyter notebooks actually this whole entire time. So if you don't have Jupyter Notebook installed already, you can type pip install Jupyter Lab in your terminal. But let's talk about some of these fundamental Python packages that we've been using this time. So the first one I want to talk about is NumPy, which is a fundamental package for scientific computing in Python. And its most handy feature is facilitating array-like math and data storage. So you can install NumPy, and this is SciPy, a library for adding functionality to standard Python for that would be useful to scientists, mathematicians, and engineers. And one feature that I really like is the linear regression package. We're going to be talking about that today. And Matplotlib is a plotting tool for data visualization. I believe that you've used Matplotlib in some other tracks this week. Pandas is a tool used to read and manipulate data sets. It represents data as data frame objects and makes them easier to handle in raw Python data types. And so you'll need to install these 4 dependencies if you want to use pandas. And then you can just simply type pip install pandas to get that. So I just wanted to go over that and make sure that you all have a little familiarity with those concepts before we dive in to our notebooks. And actually, I'm going to transition to the Visual Studio Code editor so that we can all go through this in real time. Okay. So this is pretty relevant data for these days. I don't know if you all are familiar with Taylor Swift, but she's going to be having is currently having a huge concert tour in the United States, in Europe, in Asia, I think maybe even more places. And so I thought it would be good to revisit this code. We have Taylor Swift song records, and Taylor Swift has so many different song records. So I thought this would be a big enough data set for us to actually play with today. And I wanted to work on this with all of you. So first, we need to install NumPy and Pandas. And so the reason we install these libraries is, it's exactly how we were talking about earlier. This is a way to, use data frames, which are these pandas objects, to sort our data and describe Taylor Swift's catalog. So we are going to focus on descriptive statistics, which are statistics that describe the data set, like the mean and the max. And we could even look for outliers in this data set. So maybe we will do that as well. All right, so we'll begin by loading in the CSV file. I think we already have done this a little bit before, so hopefully this should be familiar to you. And now that we have the data in our notebook, let's look at the data itself. And we can do this by printing the column names or even just checking the first few values of the data table. So by typing df.columns, you can see that this is the different data that Spotify gives us on each of Taylor Swift's tracks. So it tells us the artist name and album ID, album type, and so on. And so, yeah, this is a lot of information, a lot of different features for each data entry. I wanted to actually address a comment in the stream here from Zadesh saying, I had a quick question from the previous discussion. Does outlier and anomaly mean the same? And actually, I would say no. So anomaly typically means any deviation from the mean. So imagine that this year it's hotter than average. You could say that there is a temperature anomaly. But if it is an outlier, it will also be way outside anything ever experienced. And so that actually is a stronger bar, and it may still be an outlier, but it doesn't necessarily have to be an outlier if it's an anomaly. All right. So, yeah, when you visualize this data frame, which we can do by just typing df, you'll see there's so many different tracks here. And these are I really like these scores here. This is so interesting. There's a danceability score. So I guess this Lavender Haze track is super danceable. And there's an energy score. So the energy score here is pretty high, but not as high as something like Only Me When I'm With You, and something like that. So it's kind of interesting to learn about this stuff through the Spotify data. You can see how many columns there are in this data set. Um, and so if we sort of take the rows times the columns, we can see that we have 45,000 pieces of information in this data set. Bugger's right. Yeah, you definitely can drop the URL column. Oh, so it looks like maybe we're dealing with similar data, so that's good. Hopefully, we can maybe talk about that a little bit today. Because I have a little bit of data pre-processing in this notebook too. So you may want to try and do some of the same stuff. So now let's move on to generating some descriptive statistics. So this one is, what is the average length of a Taylor Swift song? So all we do is we take np.mean, numpy mean of the duration column, and we find that it's 230,000 milliseconds. And I actually built this function to convert that into a minutes and seconds. And when we run that function, we find that this means the average Taylor Swift song is 3 minutes and 50 seconds. All right. So one of the purposes of generating descriptive statistics is to see how well our data set compares to another. And so let's see how Taylor Swift's song length compares to other modern pop songs. And actually, the average over recent years is 3 minutes and 50 seconds too. So you can check that source over there. Kind of interesting um, to learn about. But the average tempo of a pop song is 116, and the average tempo of Taylor Swift's songs is a little higher than that, almost 121. And the way you can figure that out is by typing np.mean of the tempo. I also used this round method, oops, sorry, which rounds this answer to the nearest three decimals. So actually, I could just round it to the nearest number. What are the top three keys that Taylor Swift likes to write in? Well, we have this column key mode, and we can use the value counts method to count the frequency of each appearance. So when we do that, we find that G major is the most popular key, followed by F and then C major, which are pretty closely tied. So major keys are really a lot more popular in pop songs, a lot more common. So we're not exactly surprised by that. And this last line here shows that those top three keys are 42% of all the Taylor Swift songs. So if you get a Taylor Swift song, there's a 40% chance it's written in G, F, or C major. All right, so here's that data cleaning that I was talking about earlier. And this is something you may want to consider to do as well, Asmam. Um, so um, sometimes the original raw data set that we get from the real world is not what we want to analyze. So let's list all of the Taylor Swift albums on Spotify. So here's all the albums, right? And you can see that a lot of these albums are actually duplicates. Um, so, for example, um, we have this Midnight's 3 a.m. edition. And then we have Midnight's here. So if we want to know just the unique albums here, we can remove any entries which have these parentheses around them. And if we do that, I have that code here. And I also removed the karaoke songs. We can just get the unique albums. So we find that actually there's a lot less albums. And we could even, if we think that live albums, we want to eliminate any live albums, we could do that as well. And then here we have, I'm trying to open the club and I need some music to play. What's Taylor Swift's most danceable song? And we get the track name, I Think He Knows. Very danceable song. I'm actually curious, what is the max dance here? Oh, 897, that's really high. Kind of a funny thing to measure, though. I still think it's really funny. All right, so you've already performed cleaning, so that's good. Yeah, you may want to, to think about this. So there's another way to augment your data, and it's by transforming your data. So when you're removing all those duplicates, you could consider that to be removing the data, and maybe that will improve the model's performance if you don't remove those duplicates. So worth trying. Yeah. All right. Well, I wanted to cover one more section here, which is about correlation. And this is one last concept that I think I want to talk about today, before we finish. I apologize for the smaller session today, but I think I sort of went a little faster than usual and through this content. So with the correlation notebook here, which you should also have access to through the repository, let's go ahead and run this library here. And we're going to go to this city data set. We didn't actually analyze this data set before, but I actually have it just hard coded into this notebook. So all you have to do is run, and then it will be accessible via capital data variable. So you just run that. And this data set has 4 variables: has state, capital, area, which is in square meters, I believe, and then population, which is in thousands of people. I'm sorry, square kilometers, I think, or it could be square miles too. And so we want to know if there's a correlation between U.S. state capital area and population. So we can use a linear regression to figure that out. And it tells us that there is a 0.03 correlation, which is extremely low, right? And so just by looking at these numbers, it can be kind of difficult to tell whether there's really anything there. So let's plot just to make sure that there really is no relationship. And you can see from this plot that actually we have an outlier, and the outlier is right up here in the top left corner. And so if we want to remove that, we can filter out the data. We can actually look at what that is. It's Alaska's capital, which has a large area and a small population. So I want you all to try this on your own. I'll give you maybe not as long as last time, maybe 5 minutes. I want to see if you all can figure out how to remove this this data, and see if you can find a correlation. Oh, and then after this, I'll take some questions. So I see that there's a few questions in the chat, and we will go over those before we finish. So definitely we'll get to those. All right, everybody. So that is concludes our 5 minutes time there, and I hope you're able to then remove that outlier and see that our data set then becomes correlated. So let's take a look at that. So when we remove that row, which is that Alaskan row there, we get a correlation of 0.62. All right, and that's much higher, and this is indicating a moderate relationship. And so now, is there any way that we can get the average population density of the capitals from our regression? Well, we can get that from saying the slope. So if we calculate the slope, we see that the average U.S. state capital has a population of 1875 people per square mile. And are there cases where we cannot perform a linear regression? Absolutely. So if the variation is too low in either dimension, especially the x dimension, then we will actually not be able to do linear regression. Also, if the residuals are not normally distributed, and you might be asking, what does that mean? Well, we'll test that below. If the data set is heteroscedastic, so that means that the variance of the data set is changing with some variable, increasing in some variable, and if the correlation is spurious. So this is kind of an interesting one to check out if you're interested in spurious correlations. That website gives a lot of examples of kind of kooky correlations that are not real, but they're not real effects, but they do have a real correlation. Right, so these are our residuals here. So residual means it means the real population value subtracted from the predictions of our model. And so if we have our population and area variables, these are our features of our model. We can then use the linear regression parameters to calculate the predicted values and subtract those and compute the residual. All right. And so here's our residuals. And you can see that we have a relatively normal distribution where most of the data is concentrated around 0 with a few outliers on either side. But yeah, and it's almost symmetric, although their team seems to be a little bit of a skew to the right, which means that more extreme values are concentrated over there. But overall, it's relatively normal. But we could definitely use a better model than linear regression, is what this is indicating. It would definitely be possible. So that sort of concludes the correlation page. And now I wanted to turn to some questions so we can wrap up our sessions. So first one is, any suggestions on how we could deploy a model and maybe use endpoints so that we could call it using an API request? Yeah, you absolutely can do that. So I would suggest that you learn a little bit about some kind of framework, maybe a web app framework, where you can write endpoints to a backend server, which will have your algorithm on it. And then that algorithm could run on the server side and return you information. And actually, that's what happens with ChatGPT. So ChatGPT is a web app which has the server-side model, and you can access that server-side model through making any kind of request. So whenever you send a new prompt to ChatGPT, it'll return those outputs. So, definitely learning things like React or Flask, Node.js, any of these technologies which are have endpoint handling in them, would be really, really useful. So I highly recommend you check that out if you're interested in building some kind of machine learning algorithm that you can call through API requests. And actually, I believe there's a previous Global Hack Week stream by Ryan Swift called Building Your Own API. And that might be a good place to start too. Let me see if I can find that for you real quick. Okay, yes, I think I found it. So he uses one of those technologies which I mentioned, which is Python Flask. And that would be a great place to start if you're interested in doing such a thing. Maruti asks, what does negative correlation and positive correlation mean? That's a great question too. So negative correlation means that when you increase one variable, the other one decreases on the whole. Positive correlation means that when you increase one variable, the other one also increases. So in our example, which is our cities example, I'll go back to that screen actually. You can see that, okay, actually let's plot capital data clean, because it'll be easier to see that way. So if we print R, if R is positive, we have a positive correlation. So R is 0.79. And you can see as we increase the population variable, so I'll actually put some labels on this plot so it's easier for you to see. The area of the city also must increase, right? Oops. And that's showing a positive correlation. And yeah, here's another idea by Bugbreaker. I've done that while doing a gold price prediction, correlation between multiple features. Can also use that for feature selection. Yes. This is, I believe, referring to, let's see, is there another? I think someone mentioned matrix correlation. Here it is. Yes. Why did you use linear correlation to see correlation and not the matrix correlation? Well, matrix correlation tells you the correlation between the thing you want to predict and many different variables. In this example, we really only have two variables, so the matrix correlation is equal to the regression correlation. But as Bugbreaker says, matrix correlation is for analysis, while regression is for prediction. And you can actually use a matrix correlation for feature selection, feature engineering. I think someone else asked about feature engineering. I would highly recommend you check out this concept of matrix correlation. But yeah, folks, thank you for your questions, and thank you all for attending these sessions. I've seen some of you here for all four of these sessions, and it honestly means a lot to me that you enjoy it enough to come back on your own time and learn with us. And I also really enjoy all the questions that you have and the energy you bring to these workshops. That's a main reason why we do the Global Hack Week live. So that you all are here with us. And I really appreciate it personally. So thank you so much for joining today. And once again, I'd love to connect if anybody wants to connect over LinkedIn. And yeah, if you have any follow-up questions or just want to update us on your journey, please feel free to reach out. But yeah, thank you for the kind words, Maruti and Usman and everyone. And we'll be signing off now.